What do a sandwich, potato wedges, and pasta have in common? That's right, cheese. It takes these simple dishes and turns them into pure bliss. There are plenty of cheeses in the world, but cheddar holds a special place in my heart. Today we're diving into my love story with this cheese, my go-to for the easiest, most delicious meals I know. Let's get started. At the cheese factory where cheddar is made, pasteurization is like a technological dance. By the way, are you into techno? The process kicks off with an automated system moving milk through a network of sterile pipes to a pasteurization unit. Here, heat exchangers warm the milk to an exact temperature, typically between 161 and 167 degrees Fahrenheit. It's not just heating, it's a precision process that destroys harmful microorganisms while keeping the milk's nutrients intact. The secret lies in the control system. High-precision sensors continuously monitor the milk's temperature. Once the milk has been heated for the required time, it's cooled down almost instantly to a safe 39 degrees Fahrenheit. Here's where it gets innovative. The heat released during cooling is reused to warm the next batch of milk. This energy regeneration is both cost-effective and eco-friendly, reducing the production's overall energy consumption. In the warm halls of the cheese factory, where the milk has already been pasteurized, the next step begins, adding the starter culture and rennet. The pasteurized milk is poured into large stainless steel vats, where it's heated to around 86 to 89 degrees Fahrenheit, the perfect temperature for the starter culture to do its magic. A computer system controls every detail, from the milk volume to the exact temperature in each vat. The starter culture goes in first. These are carefully selected lactic acid bacteria that give cheddar its signature flavor and texture. Delivered as either a powder or liquid, the culture is measured precisely by robotic dispensers. Once added, large mechanical paddles gently stir the milk, ensuring the bacteria are evenly distributed. Next comes the addition of rennet, a microbiological enzyme called renin. It's eco-friendly and even suitable for vegetarians. Adding rennet is where the magic happens. It transforms the milk into a curd in less than an hour, laying the foundation for cheddar. While the rennet works its magic, the system keeps an eye on every change in the milk. Sensors measure acidity and density, while algorithms determine the exact moment to end this phase. Modern technology ensures the process is quick, efficient, and requires minimal human intervention. Once the curd is fully formed, the milk is no longer a liquid. It has become a smooth, tender cheese mass ready for the next step in becoming the famous cheddar. Cheddar is the reason I took my first steps in cooking. Actually, I've taken a lot of steps since then, but I still feel like I'm standing in the same spot. But let's not talk about that. Let's talk about 10-year-old me trying to cook for the first time. Picture this. Me, a heated pan. My mom watching from the corner of the kitchen, ready to call 911 if needed. And there they were. 2 slices of bread slathered with butter and a generous slice of cheddar. Sure, the bread got a little burnt, but it still tasted incredible. By the way, what was the first thing you ever cooked? Forming the curd is when cheddar starts to take physical shape. Every parameter, temperature, acidity level, enzyme timing, is carefully monitored. Sensors continuously measure the milk's density to determine when the curd has reached the ideal consistency, which takes about 30 to 40 minutes. Look at this giant vat. The milk seems to have frozen in time, turning into a soft, gel-like curd. Once the sensors confirm the curd's structure, special knives come into play. These are automated paddles fitted with blades that gently cut the curd into small cubes. They move slowly and evenly to maintain uniformity, which is essential for separating the whey later. At the same time, the vat is gradually heated to around 100 to 104 degrees Fahrenheit. This secondary heating helps expel whey and solidify the cheese granules. As the whey separates during heating, it's drained through special valves at the bottom of the vat. This process is also automated, ensuring just the right amount of whey is left to maintain the cheese mass's proper consistency. What remains in the vat is dense yet tender curd, ready for the cheddaring process. You've been waiting for this part, haven't you? The curd, now formed into large chunks, is transferred to special tables or conveyor belts made of stainless steel with built-in heating systems to maintain the optimal cheddaring temperature of around 95 to 100 degrees Fahrenheit. The curd is stacked into layers, distributed evenly by robotic manipulators or conveyor systems. These layers rest for a specific time, allowing them to bond and compress. Under its own weight and the steady temperature, the curd releases residual whey. After a certain period, the layers are flipped over. A key feature of the cheddaring process is the gradual acidification of the curd. This happens thanks to the lactic acid bacteria added earlier with the starter culture. Their activity alters the cheese's chemical composition, giving it a mild, slightly tangy flavor. By the time cheddaring is complete, the curd becomes dense, elastic, and ready for the next step, cutting and salting. Automated cutting systems divide the curd into equal pieces, ensuring consistent weight and size for every portion. At this point, my friend, we're one step closer to achieving cheddar's authentic flavor and texture. Now the curd, firm and springy, moves along specialized conveyors. Come closer and take a look. This is where the curd is cut into blocks or cubes, depending on the intended product. Next, it's time for salting. In the US, two main salting methods are used: brine baths and dry salting. The choice depends on the recipe for each batch of cheddar. In brine baths, large tanks are filled with a salt solution, where the cheese is submerged for several hours to allow the salt to penetrate its structure. For dry salting, the cheese blocks travel along a conveyor, passing through machines that evenly sprinkle salt over them. Salt serves a dual purpose. It enhances flavor and acts as a natural preservative, protecting the cheese from unwanted microorganisms. During this stage, the cheese continues to release residual whey, which automated systems collect and process for further use or recycling. And now, it's time for aging. This, by the way, is something I have zero patience for when it comes to cheddar. The cheese blocks are sent to special aging rooms, also known as maturation chambers. These chambers are equipped with modern climate control systems that automatically maintain optimal conditions for cheddar to age. Temperature, humidity, and air circulation are regulated with precision, down to the tenth of a degree or percentage, because even the slightest deviation can impact the cheese's quality. Cheddar is typically aged anywhere from a few months to several years. Young cheddar has a mild, creamy taste, while aged cheddar develops a rich, tangy flavor with a crystalline texture. The aging duration is determined during the batch planning stage, and all parameters are recorded in a centralized computer system. Robotic manipulators carefully stack the cheese blocks on racks in the aging chambers. These robots are programmed to minimize contact with the product, ensuring a high level of hygiene. The rack systems are also automated, capable of rotating or moving the blocks for even aging. Throughout the aging process, the cheese is closely monitored. Automatic sensors in the chambers continuously check the microclimate and even analyze gases released by the cheese to track chemical changes in its structure. In some cases, cheddar is coated with a layer of wax or a special film to protect it from drying out and environmental exposure. For aged varieties, dry aging is sometimes used, leaving the cheese uncovered to form a natural rind. When this method is chosen, automated systems periodically move and flip the blocks, cleaning them of any accumulated dust or mold. In this video, we'll dive into the fascinating world of massive conveyor belts and fully automated production lines, where simple ingredients are transformed into sweet masterpieces in just minutes. Get ready to uncover the industry secrets you never knew existed. Cake factories in the United States and worldwide purchase ingredients in volumes that match the scale of their production. They typically sign contracts with large ingredient suppliers, such as producers of flour, sugar, butter, eggs, dairy products, and flavorings. These suppliers can deliver consistent, large-scale shipments and often adhere to strict quality standards, which is crucial for maintaining the taste and quality of the final product. Core ingredients like wheat flour are usually bought from large manufacturers or cooperatives, while specialized ingredients like flavorings or colorings may be sourced from specialty companies. Logistics companies deliver these products directly to factories, often in refrigerated or sealed containers to keep everything fresh. Some ingredients like chocolate or exotic fruits are imported from producing countries. Chocolate from Latin America, for instance, since this can offer better quality or pricing compared to local sources. Imagine that the ingredients in your dessert might have traveled from nearly every part of the world. Modern cake production is fully automated, with ingredients added to the mixer via conveyor systems and dispensers, requiring no human intervention. For instance, dry and liquid ingredients are added using dosing and weighing systems. Each ingredient comes from its own container, fed through automated pipes or funnels that accurately measure and deliver the required amount into a large industrial mixer. Flour, salt, and sugar are dispensed from bins or containers through piping systems. They pass through dispensers that precisely control weight and quantity before being moved on a conveyor to the mixer. Butter, milk, water, and eggs are fed through special pump systems that control liquid flow, connected to dispensers that automatically add the exact amount of liquid ingredients into the mixer. At large factories, eggs are often used in the form of pasteurized liquid egg mixtures, stored in refrigerated containers. When whole eggs are needed, they are automatically cracked by special machines, with the shells separated, leaving just the egg mass for mixing. All these ingredients are then combined in the large mixer for blending. After mixing, the batter is directed to specialized dosing and filling machines that precisely measure and dispense it into baking molds. The batter from the mixer travels through a conveyor or pumping system to the dosing station. A holding tank or container is used to store the batter temporarily for convenience until the next step. Pumping equipment regulates the batter flow to ensure smooth, continuous transfer. At this stage, the dispenser carefully measures the batter volume that will be distributed into the molds. Dosing mechanisms are set to provide each mold with the exact amount of batter, which is crucial for achieving consistent cake sizes. Some systems use volumetric dosing, which measures batter by volume, or weight-based dosing to ensure the precise weight of each product. An automatic filling head distributes the batter into pre-arranged molds on a conveyor. As the molds move under the dosing head, the filling mechanism releases the required amount of batter directly into each one. These molds may be round or rectangular, depending on the product type. To avoid overfilling or underfilling, dispensers are equipped with a feedback system that adjusts batter amounts based on weight or volume data. Some filling machines have sensors that monitor filling levels and automatically stop once the correct amount of batter is reached. After the batter is poured into molds, the conveyor moves them into specialized industrial ovens. In large-scale production, tunnel ovens are used, where the conveyor with molds passes continuously from one side to the other. The baking temperature and time are carefully calibrated for each type of batter. These ovens are preheated to specific temperatures, typically ranging from 302 to 356 degrees Fahrenheit for cakes. The ovens maintain a steady temperature and control humidity levels, with modern models equipped with automatic temperature control systems to ensure even baking. It's crucial to maintain consistent heat distribution and optimal moisture levels during baking. Industrial ovens are often equipped with steam injection or ventilation systems to manage humidity, helping to create the perfect crust and texture for the cakes. The conveyor moves at a speed that allows each product to bake for the optimal amount of time, typically 20 to 30 minutes. Tunnel ovens feature adjustable temperature zones, so the batter rises at the beginning of baking and achieves an even color and texture by the end. This automated process allows for the simultaneous baking of thousands of cakes. After baking, the conveyor moves the molds with freshly baked cakes onto a cooling line, where they rest to stabilize their temperature. This step is crucial to prevent deformation and ensure perfect texture. Cooling usually happens via fans that blow cool air over the cakes. As soon as the cakes exit the oven, the conveyor transfers them onto a designated cooling line. At this stage, the cakes are still very hot, so gradual cooling is essential to prevent cracking. On the cooling line, fans or air conditioning systems blow cool air evenly over the cakes. The fans operate at multiple levels to cool the cakes uniformly from all sides, avoiding sudden temperature changes. I have to say, after my air conditioner broke this summer, I could have really used a tour like this to escape those 2 weeks without cool air. Some factories use spiral coolers, which are conveyors coiled in a spiral, allowing cakes to move upward and cool gradually along the way. This design saves space and provides ample time for gradual cooling. perfect for high-volume production. To prevent excessive drying, the cooling areas maintain an optimal humidity level. Some cooling systems even allow humidity adjustment to prevent the cake surfaces from drying out and to keep them looking fresh and appealing. Once the cakes are cooled, they move along the line where they are prepared for filling. All the necessary ingredients for the cream, such as buttercream, ganache, or other types of fillings, are pre-prepared and stored in large barrels or tanks. Automatic pump systems allow the cream to be transported directly from the tanks to the application area. This shortens the processing time and reduces the risk of contamination. The pumps maintain the required pressure so that the cream flows smoothly to the filling machines. The cakes are then lifted onto a special conveyor with a mechanism that has small fingers to gently hold each cake in place. Automatic machines apply the cream on the top of each cake, typically using sprayers or nozzles that distribute the cream evenly over the surface. If the cake has multiple layers, the mechanism automatically separates the cake into layers, applying cream between each one. This process also happens via conveyors that move each layer to the cream applicator and then return it to its original position. Fascinating, isn't it? After filling, the cake proceeds to the assembly stage. Here, special systems pick up each layer one at a time and stack them in the correct order. The machines may use different mechanisms, such as tongs, suction devices, or other technologies, to assemble the cake precisely without damaging it. Now comes the most exciting part: decorating the finished cakes. This is the stage that almost makes my mouth water, as it's nearly impossible to stay calm watching such artistry in action. After assembly, the cakes move to the decorating line. All the necessary materials, such as creams, glazes, fruit fillings, and other decorations, are prepared in advance and stored under controlled conditions. The cakes travel on a conveyor to a machine that automatically applies the glaze. This can be done using sprayers or injectors that form an even layer of glaze over the cake's surface. Next, a decorative pattern may be applied to the cake. This is achieved with special sprayers that create intricate designs using cream or glaze. Stencils or specialized machines may also be used to create embossed patterns automatically. Various decorative elements can be added to the cakes, including berries, nuts, chocolate pieces, sugar flowers, and other embellishments. Automated systems or robotic arms can carefully place these decorations, ensuring they're evenly distributed for a visually pleasing effect. During this stage, final touches like sprinkles of chocolate shavings, powdered sugar, or other toppings can also be added. Once decoration is complete, the finished cakes are transferred to an automated packaging line. Here they may be packed into boxes, wrapped in protective film, or otherwise prepared for transport. Have you ever wondered how simple ingredients come together to create 100 tons of the legendary Nutella? We start with 20 tons of hazelnuts from Turkey, 15 tons of sugar, and 10 tons of cocoa from Ghana, transforming them into a flavor loved by millions. From the chocolate shortages during the war to millions of jars on store shelves today, are you ready to discover how the magic happens at each step? Let's dive in. Nutella was created in Italy during World War II when chocolate was in short supply. Confectioner Pietro Ferrero mixed hazelnuts with chocolate to create a more affordable product. Originally, his recipe was called pasta gianduja, but it was eventually transformed into Nutella, which was released in 1964. Today, this chocolate hazelnut delight is available to everyone, and I'm here to walk you through the entire process, from cocoa beans in Ghana to the finished product on store shelves. Let's start with an analysis of the production plans. Here are some numbers for you. If 100 tons of Nutella are planned for production, we need to calculate the required amount of ingredients. That means around 20 tons of hazelnuts, 15 tons of sugar, 10 tons of cocoa powder, 8 tons of palm oil, 5 tons of powdered milk, and 440 pounds of vanilla. The ordering process with our trusted suppliers begins, usually from Turkey, Africa, Malaysia, and our local farms. The purchase order is based on analytical forecasts, aiming to optimize the production process and maintain top-quality raw materials. For example, 20 tons of hazelnuts are ordered 2 months before production to ensure they are fresh. Next comes the logistics. Every detail must be carefully planned since the raw materials are sourced from different corners of the world. Hazelnuts are shipped from Turkey, cocoa powder comes from Ghana, and palm oil makes its way to our warehouses by sea from Malaysia, which means transportation can take about 4 to 6 weeks. Once the goods arrive, the raw materials are stored in dry, dark facilities with strict temperature controls kept between 59 and 68 degrees Fahrenheit to prevent spoilage and oxidation. Detailed record keeping of each batch is also essential, ensuring that we can trace their origins and meet food safety standards. This step is crucial for maintaining the high quality of the final product and adhering to environmental and ethical standards. Even though the hazelnuts are shipped in specialized containers to prevent damage, they undergo a thorough quality check before processing, just like the other ingredients. This involves using contactless sensors that measure moisture levels and temperature upon receipt. The moisture content must not exceed 8%. Additionally, a visual inspection is carried out using high-resolution cameras that detect defective nuts and any foreign particles. If defects are detected, the system automatically separates them. The hazelnuts are then cleaned in automated cleaning machines, with each batch handling 1 ton of hazelnuts at a time. The process takes around 30 minutes, during which air streams remove the skins and other light particles. Quality control is maintained through sensors that monitor airflow speed and adjust the intensity of the cleaning process in real time. The cleaned hazelnuts are then automatically transferred to roasting ovens. We set the temperature between 320 and 360 degrees Fahrenheit and wait for about 15 to 20 minutes. The ovens are equipped with automated thermal sensors that monitor temperature and humidity levels. If the humidity exceeds 1%, the system automatically adjusts the roasting parameters. After roasting, the hazelnuts are moved into cooling chambers, which ensure rapid cooling to room temperature between 68 and 77 degrees Fahrenheit. This cooling process takes approximately 30 minutes. The chambers are also equipped with sensors to maintain consistent temperatures for even cooling. Next, the hazelnuts go into automated grinding machines with a capacity of up to 2 tons at a time. The grinding process takes about 10 to 15 minutes. These machines are equipped with control systems that ensure the desired paste consistency is achieved. The key objective is to reach a 50% oil content, which is essential for achieving a smooth texture. Do you smell that? I call it the scent of magic, when a few simple ingredients transform into a flavor everyone knows. Now, we're moving on to the mixing process, so let's take a closer look at how it all happens. In large mixers with a capacity of up to 30 tons, all the ingredients are loaded in. These mixers come equipped with automatic speed controllers, allowing the blade rotation speed to be adjusted based on the consistency of the mixture. We set the speed to 60 revolutions per minute and wait about 20 to 30 minutes for the process to finish. During mixing, it's crucial to monitor the temperature, as it affects the final texture of the product. The mixers are equipped with temperature sensors that automatically adjust cooling if the temperature exceeds 86 degrees Fahrenheit. Workers receive real-time temperature data, allowing for quick adjustments whenever needed. An essential process we'll discuss now is emulsification. Emulsifiers in Nutella play a key role in ensuring a smooth texture, preserving flavor, and extending the product's shelf life. For emulsification, an automated system is used for precise dosing of emulsifiers, which typically make up about 1 to 2% of the total mixture. A common choice is soy lecithin. The system ensures accuracy up to 0.1%, which is critical for the stability of the final product. The prepared mixture is then loaded into automated emulsifiers with a capacity of up to 30 tons. The emulsifier is equipped with paddle stirrers that can operate at speeds of up to 1,000 revolutions per minute, enabling rapid and efficient mixing. It's crucial to monitor the temperature of the mixture, which should not exceed 105 degrees Fahrenheit, to prevent oil breakdown and preserve flavor. To maintain this, the emulsifier is equipped with thermostats. If the temperature starts to rise, the system automatically activates cooling elements, keeping the conditions optimal. During emulsification, workers monitor the viscosity of the mixture using automated sensors. The ideal viscosity for Nutella is about 20 to 30 Pascal seconds. If the viscosity is too high or too low, the system automatically adjusts the mixing speed or adds oil to achieve the desired consistency. After the emulsification process is complete, about 30 tons of finished mixture is produced, with a temperature of around 105 degrees Fahrenheit. This temperature helps maintain the uniformity and texture of the emulsion. The finished mixture is automatically pumped into cooling tanks. The system has a capacity of around 265 gallons per minute, allowing for rapid processing of large volumes. The cooling tanks are equipped with automated cooling systems that can bring the temperature down to 68 degrees Fahrenheit within 30 to 40 minutes. Temperature is monitored in real time, using sensors to maintain stability throughout the entire process. During the cooling stage, the moisture content of the emulsion is also carefully monitored. The ideal moisture level should not exceed 5%. If the humidity is higher than the standard, the system automatically activates dehydrators to remove excess moisture. This step is crucial for ensuring a longer shelf life for the product. The finished Nutella is automatically pumped into filling machines using pumps with a capacity of up to 265 gallons per minute. The filling machines automatically portion the Nutella into jars with a volume of 14 ounces. Each jar weighs about 1 pound, including the packaging. The system ensures accurate filling with a tolerance of up to 1%, achieved through automated scales that weigh each jar during the filling process. After filling, the jars pass through an automated capping machine. It uses airtight lids to ensure long-term freshness, and the machine can cap up to 600 jars per hour, enabling the efficient processing of large volumes. Next, the jars are labeled using an automated labeling machine, which can label up to 500 jars per minute. Before starting the process, it's essential to check that the label hopper is stocked with enough labels. Each label includes information about the product, ingredients, expiration date, and barcode. Labels are applied with an accuracy of 0.02 inches, thanks to sensors that monitor the position of the jars on the conveyor belt. The system automatically checks for proper label placement and detects any defects, such as misalignment or missing labels. If the system identifies an issue, it automatically halts the machine, preventing errors in production. After labeling, the jars are automatically transferred to the packing machine. Here, they are arranged into cardboard boxes, with 12 jars per box. The packing process operates at a speed of up to 300 boxes per hour. The boxes are formed automatically without the use of glue, utilizing specialized mechanisms that ensure both speed and reliability. During packing, the system monitors the proper arrangement of jars within each box. If a box is missing jars, or if they are incorrectly placed, the system triggers an error alert. Each box is equipped with internal dividers to prevent damage to the jars during transportation. The finished boxes are then automatically fed onto a conveyor where they are stacked onto pallets, typically with about 100 boxes per pallet. Each pallet is labeled with information about its contents, making subsequent storage and transportation easier to manage. After the packing process is complete, the quantity of finished Nutella pallets is checked, usually around 200 pallets per day, with each pallet holding 100 boxes containing jars of Nutella, each with a volume of 14 ounces. An automated warehouse management system generates routes for forklifts, which transport the pallets throughout the warehouse. In the loading zone, specialized hydraulic lifts come into play, automatically raising pallets to the height of the truck's cargo area. Typically, a single truck can hold up to 30 pallets. Each truck is provided with automatically generated labels that include information about the contents, production date, expiration date, and final destination. The trucks then head out to distribution centers located up to 500 miles from the plant. The transportation status is monitored through a GPS system, allowing real-time tracking of each vehicle's location. When a truck arrives at the distribution center, the pallets are scanned again to confirm receipt, and they're then prepped for their next journey to supermarkets and into the hands of eager customers.